Hi everyone. In this video we are going to practice rationalizing denominators. So when you have a fraction, you can look at the denominator and you can ask, is it a rational number? If it's not a rational number, we can take some steps to make sure that it is. And that's important to do. It's an important step in simplification. So let me give you an example here. Let's look at 10 over the square root of 6. Square root of 6 is not a rational number. What's a rational number? A rational number is a number that can be expressed as a fraction of two integers. Well, you can't do that with root 6. It's not possible to do that. So what we want to do is rewrite it in a way that it is a rational number. One thing I know that I can do with fractions is that I'm always allowed to multiply the numerator and denominator by any non-zero number I want. Now, if I want to get rid of the radical here, I can just multiply by square root of 6, because root 6 times root 6 is just 6. So that's what I'm going to do. I'm going to take this fraction, and I'm going to multiply the numerator denominator by root 6. Okay, well, let's see what happens. 10 times root 6, well, that's just 10 root 6. No better way to write it than that. What happens in the denominator? Well, root 6 times root 6, we said that that becomes 6. It's the square root of 6 squared. So I just get this. And look what I've done. I have an irrational number here. That can't be represented as a fraction of two integers. And I have a rational number here. 6 is a rational number. It can be expressed as a fraction of two integers, 6 over 1. So there we have it. We're done. That's all you got to do. You want to rationalize the denominator with a square root, just multiply the numerator and denominator by that square root. It's as simple as that. Let's try another one. Let's try the square root of 4 over 27. Okay, well, let's start simplifying this. One of the things we can do is we can write this as the square root of 4 over the square root of 27. Now, you might just say, well, let's just do what we did up here and just multiply the numerator and denominator by root 27. And that will work. That will work. But I think that there's a little bit quicker way, a little bit cleaner way to do this, is to simplify these radicals first. If you ever are at a point in a problem where you can simplify it, I would stop and simplify it right then and there, because you're going to make everything simpler from then on out. So let's do it. Square root of 4, that simplifies quite nicely. That becomes 2. What about the square root of 27? Well, okay. That one's not as easy. 27 isn't a perfect square, but it does have a perfect square factor, 9. So let's factor out that 9. 27 is 9 times 3, right? So the square root of 9 is 3, and then the square root of 3 is left over. So we simplify it to this fraction here. And I still want to rationalize the denominator. I don't want this irrational number down here. The 3 is fine. That's rational. Square root of 3, not rational. So I'm going to do the same trick we did up here. Multiply the numerator and denominator by root 3. Let's see what we get. 2 times root 3 is 2 root 3. 3 times root 3 times root 3. Okay, well, root 3 times root 3 is just 3. All right, so this just becomes 3 times 3. Well, we can simplify that. We know what 3 times 3 is. It's 9. So there is our final answer. So it's a little more work on that one. We had to do some simplification first, but we still got to a rational denominator. All right. Let's try something a little more interesting. Let's try something with cubed roots instead of square roots. Let's start with something very simple. Let's just take 8 over the cubed root of 5. Okay? And let's see what we can do with this. Now, if you look at what we did up here, you might be tempted to say, well, we'll just multiply the numerator and denominator by cubed root of 5. Well, that's not quite going to work. And why not? Well, what made it work here? Well, it's because square root of 6 times square root of 6 is just an integer, 6. But that's not the case for cubed root of 5. Cubed root of 5 times cubed root of 5 is not 5. It's the cubed root of 5 squared. It's not 5. What do I have to do to this to get a rational number? Well, I have to cube it. To undo the cubed root, I need to cube it. In other words, I need to multiply by cubed root of 5 times cubed root of 5, so that I have 3 cubed root of 5s. That's cubed root of 5 cubed. So that's what we're going to do. We are going to multiply the numerator and denominator of this fraction by cubed root of 5 times cubed root of 5 times cubed root of 5, cubed root of 5. If I do it to the denominator, I have to also do it to the numerator. So now look what I got in the bottom. Cubed root of 5 cubed. I got 3 of them, so this becomes 5 in the denominator. If I take the cubed root of something and then cube it, 1, 2, 3, I just get that something. So that's what I have to do here. What happens to the numerator? Well, I have the cubed root of 5 times the cubed root of 5. I can combine these. 5 times 5. All right? So this becomes 8 times the cubed root of 25 divided by 5. And that is my final answer. So when it's not a square root, if it's a different index, you've got to multiply by that thing 3 times. Or if you think about what we did there and look at this last step, we simplified this right here. Cubed root of 5 times cubed root of 5 became cubed root of 5 squared. So that would have been another approach. Instead of doing this up here, we could have just done, start with the original problem, 8 over cubed root of 5, and just multiplied by cubed root of 5 squared in the numerator and denominator. Right. And what happens here? Well, I get the cubed root of 5 cubed down here, so that's just 5, and I get 8 times the cubed root of 25 here. It's quicker, it gets us to the same place. And the whole point here is that when I have 5 times the 5 squared, I get an exponent of 3, which matches the index of the root. And that's really what we need to get. Let's do another one involving a variable. So let's try the 4th root. Let's try 4 over the 4th root of 4x squared. Okay, so I want to get rid of this thing. So how do I make this so it doesn't have a root anymore, a radical? Well, I could multiply by, I want to end up with 4 copies of this thing so that it's the same thing as this to the 4th power, and that cancels out the root. So in other words, I need to multiply by 3 more of these. Or in other words, I need to multiply what I started with by the 4th root of this stuff cubed. Because altogether I've got 1, 3 more, and that makes 4 of them. So I have the 4th root of that thing to the 4th power. And that will do it. And we have to do that to the numerator and the denominator. So let's see what happens. Okay? In the denominator, I've got 4x squared times 4x squared cubed. That's 4x squared to the 4th. And then the 4th root, they undo each other. So I'm just left with 4x squared in the denominator. What happens in the numerator? Well, I've got the 4 out here, right? And then what happens to this? Well, I got 4 cubed. That's 4 times 4 is 16, times 4 is 64. And x squared cubed. Well, that's x to the 6. You multiply the exponents. Now, we can do a little bit more here. We can cancel out the 4s. What we want to do here is we want to simplify this radical here. And when you simplify a radical, if you're taking the 4th root, you want to find factors that are a power of 4. All right? 64 has a factor that's a power of 4. It has 16. Right? 16 is 2 to the 4th. I can take the 4th root of 16 and get an integer. So I want to factor out 16. All right? So I got rid of the 4s, so I'm just going to rewrite this as this in the numerator and x squared in the denominator. I said that I can factor out a 16. 64 is 16 times 4. Moreover, I can pull out a perfect fourth power out of here too. X to the 6 is x to the 4 times x squared. Okay, now whenever I have a power of 4 in here, one's here and one's here, I can pull it out of the fourth root by taking the fourth root of it. So what's the fourth root of 16? Well, it's 2. So that comes out of, 16 comes out of the radical as a 2. What about x to the 4th? If I take x to the 4th and then take the fourth root, I just get x. Just divide this by this. And what's left over in the fourth root? I got 4x squared. And so this is almost my final answer. I see one more thing I can do here. Now that I pulled the x out, I see I can actually cancel these. Look at this. There's a factor of x up here and a factor of x down there. So cross that out, subtract 1 from the exponent. I end up with 2 times the fourth root, 4x squared over x. That's my final answer. Lots of stuff happened there. But you've got the video. You can rewind and check it step by step.